Problem 3. I think that this problem is a lot harder than they intended it to be. It's definitely not for beginners, and I don't expect that you'll have to solve a problem like this either on homework or tests in this class. I'll go through it though just to show you how it works. Step 1. What we have is that force is inversely proportional to length. The variables will be force measured in pounds and length, which is given in feet, but we're going to run into a problem with the length, and I'll show you why. Step 2, the relationship is one of inverse proportion. That means F equals K divided by L. Let's move on to step 4. 150 pounds equals 512 pounds divided by L. We'll multiply both sides by L. That gives us L times 150 pounds equals 512 pounds. Divide both sides by the 150 pounds, and we have L equals 512 pound divided by 150 pound. The pound goes away, and 512 divided by 150 is 3.413. So we get L equals 3.413. The wrench needs to be 3.413 times as long as the one you have. That's what's confusing about this. L winds up being a ratio, not a length. But 3.413 feet means you need 2.413 feet more than you have. And converting that to inches, I'll put a 1 down here, 12 inches to feet. The feet will cancel, and that gives me 28.96 inches. The wrench needs to be 28.96 inches longer. Like I said, that was a tough one. I think this question would make more sense as a direct variation problem. If the force you get is directly proportional to the length of the wrench, and you get 150 pounds from a 12-inch wrench, how much longer should the wrench be to get 512 pounds? Now we have F equals KL because it's direct variation, and we're given 150 pounds equals K times 12 inches. That would mean that K equals 150 pounds over 12 inches. And that's 12.5 pounds per inch. To get 512 pounds, we'll let that be the F, equals 12.5 pounds over 1 inch times L. Now, if I multiply both of these sides by the reciprocal of this, I'll get 1 inch over 12.5 pounds times 512 pounds equals, the reciprocal times this will just be 1, so that'll just be L. And I have, now the pound will cancel, I have L equals 512 inches over 12.5, and that is going to be 40.96 inches. 40.96 minus 12 is 28.96, and that's what we got last time. But I think this perspective is a little bit easier to work with. This is problem 2 on page 55. It's another inverse variation problem, but this one's more straightforward. The time required to empty a large water tank varies inversely as the rate of pumping. If a pump can empty the tank in 2.5 hours at a rate of 400 gallons per minute, use the steps below to determine how long it will take to empty a tank at a rate of 500 gallons per minute. Step 1, choose the letters and variables. We are given time, and that'll be T, and it's measured in hours, though we'll probably convert to minutes. And we're also given the rate of pumping. So that's R, and the rate we're given is 400 gallons per minute. Rate, and that's in gallons minute. Our equation is T equals K over R. It's an inverse variation problem. So what we have is that 150 minutes equals K divided by R is the same as K times 1 over R. So I'm going to write that as K times 1 minute over 400 gallons. And now if I multiply both sides by 400 gallons, I can get rid of this. And I will have 400 times 150 60,000, and I'll have I'll have 60,000, and I'm multiplying gallons times minutes, so gallon minutes equals K times minutes, K minutes. So divide both sides by the minute cancels, and what we have then is that K equals 60,000 gallons. So K must be the size of the tank. Our formula will be T equals 60,000 divided by R. How long to empty the tank at 500 gallons per minute? We have T equals K times 1 over R, and that's going to be 60,000 gallons times the reciprocal of 500 gallons per minute will be 1 minute divided by 500 gallons. The gallon cancels, and that gives me 60,000 minutes divided by 500, which comes out to be 120 minutes. So it would take 2 hours at 500 gallons per minute. I'll also do part 3. This is a complicated joint variation problem. The number of dolls varies directly with the advertising budget and inversely with the price of the doll. First, let's list our variables. I'll have N be the number of dolls, and the unit will be dolls. I'll have B represent the advertising budget, and that will be in dollars. And I'll have P be the price of the doll, and that will also be in dollars. On one side of the equation, we'll have N by itself. There's always a K, and it varies directly with the budget, so we multiply the budget times K. It varies inversely with the price, so we're going to divide everything by P. And that's our equation, N equals KB divided by P. what we're given is that $9,600 equals K times $54,000 divided by P, which is $90. The dollars cancel and we get $9,600 equals 600 times K. Divide both sides by 600. K equals $16. Put down K equals $16. And the formula will be N equals 16B over P. Finally, how many dolls are sold when the advertising budget is $144,000 and the doll price is $100? We have N equals 16 doll times $144,000 divided by $100. The dollars signs will cancel, and that gives us, what does that give us? Looks like $23,040. That's what I get.